Hey folks, let's take a look at example 10. And example 10 has a lot packed into it. I really want to take a look at these two denominators, x minus 2 and 2 minus x, because they have the same terms, right? They both have an x and they both have a 2, but they're in flip-flopped order. And if you were doing something like addition, if I gave you something like 2 plus 7, right? And you told me, hey, Miss Barrow, that's 9, right? Great. We could flip the order. 7 plus 2 is also 9, right? So addition is commutative. It doesn't matter the order you go in. But if we took something like 2 minus 7, right? That would be negative 5. That is different than 7 minus 2, which is positive 5. So order does matter in subtraction, right? Subtraction is not commutative, whereas addition is. But these are similar, right? If you look at 2 minus 7, 7 minus 2, they're both orders of 5. It's just one is positive and one is negative. And this would play out for any two negative numbers, right? If I gave you something like 5 minus, 9, that's negative 4. 9 minus 5 is positive 4. So they have the same number, they're just opposite signs. So the idea here is x minus 2 is the opposite of 2 minus x. Right? Or what I'm saying here is x minus 2 is the opposite of 2 minus x. And if you distributed this negative through, right? Negative times 2, or negative 1 essentially times 2 is negative 2. Negative times negative x is positive x. Negative 2 plus x is the same as x minus 2. All right, and if you're not catching on to that, I'm going to erase all of this. I'm going to mess with this in a very specific way. We're still going to multiply by a very special version of 1. And then I'm going to show you yet another way to do this. So let me erase all of the shenanigans that I have on here so far. Okay. And what I'm going to do in a moment after I erase all this stuff is I'm going to multiply that second fraction by negative 1 over 1. Okay. And the only time I do this is when I see that I have a fraction or fractions with the same terms, right? An x and a 2 in this case. They're just in the opposite order and they're being subtracted. So what I'm trying to say is I'm going to rewrite this as 6 over x minus 2 plus x plus 3 over 2 minus x times negative 1 over negative 1. All right, so I'm essentially multiplying this second fraction by 1 because negative 1 over negative 1 is positive 1. But watch what this turns into, okay? So I'm going to go ahead and I'm going to write 6 over x minus 2. Now we just talked about if I had a negative and I distribute to this binomial, right? Negative 1 times positive 2. Actually, hold on, let me put the little plus sign here. All right, negative 1 times positive 2, that's going to be negative 2. Negative 1 times negative x is going to be positive x, right? And then in this numerator, I have this negative 1 getting multiplied to this binomial, right? I also have x plus 3 times negative 1 still, okay? All right, now I'm going to rewrite this with the x as the lead. So this is ultimately 6 over x minus 2 plus, okay, I'm going to write this as negative 1 times x plus 3. And then we've got x minus 2 on the denominator, right? Because I had a positive x and a negative 2, so I'm rewriting that as x minus 2. And I'm going to distribute this numerator just a little bit. And maybe you can see where I'm going because maybe you're starting to see the like terms, right? I've got negative x minus 3 up here, and then I've got x minus 2. So now I've got two fractions. We've got some like terms. So I'm going to go ahead and keep that denominator. And I'm essentially going to have 6 minus x minus 3 up here, right? Because plus negative x plus negative 3, I just keep those subtraction symbols. All right, and if I look, I have some like terms. I have a 6 and a negative 3, so I can combine those. So my end game answer here is I'm going to start with the lead negative. So I have negative x here, and then 6 minus 3 is going to be plus 3, and this is essentially over x minus 2. Right? And I can't cancel this binomial with this binomial, and I cannot cancel the x's. You can't break up a binomial. If you wanted to, let's say you don't like having the lead negative, you could rewrite this as 3 minus x over x minus 2. So those are two equivalent ways of writing that end game answer. And let me just show you how I tend to do this nowadays. And this is after a bunch of practice, right? So here's what I mean. I'll sit there and I'll say, okay, I've got 6 over x minus 2 plus x plus 3 over 2 minus x. And then I do recognize, like, because this happens often enough, I recognize that these have the same terms, right? Both have an x, both have a 2, but they're being subtracted in the opposite order. So I'll just factor out the negative from this denominator. So what I mean by that is I will keep this fraction, 6 over x minus 2. I will change this addition to subtraction, and I will change the order of that denominator. So I am essentially not changing that problem because I factored out a -1 from here, right, to make this x minus 2, and I just changed that linear operation from addition to subtraction. Okay, and then because I have common denominators, I can keep my denominator, but I have to remember to distribute this negative to this protected binomial, right? 6x minus 3, x plus 3, excuse me, 6 minus the entirety of x plus 3. So now it's time to distribute that negative. So I've got x minus 2. All right, so this is going to be 6, -1 times x, -x, -1 times positive 3, -3. And then you can see that I'm back to where I was up here, right? So this is essentially 3 minus x over x minus 2. All right, thanks so much. Bye.